Hello sir, we are from mechanical department M section. We are going to discuss a topic about truss bridge. The members involved in this project are Prashot, Mayur, Ritik, Vijit, Sumant, Jayant, Rishi, Sanjay, Shashank, Sunil, Sharanya and myself. We are going to talk about the topics are what is truss bridge and its construction, application of trusses, characteristics of trusses and types of trusses. And at last we are going to conduct the experiment. We are going to conduct the practical experiment by our beloved friends. And the further topics will be continued by my beloved friend Mike.
So, before understanding the working and the construction of a truss bridge, let us know what is meant by truss and the development of trusses. The development of trusses takes us back to the year 1952 near Pampana Beach, Florida, where an engineer named A. Carl Stanford, who is also the founder of Stanford Industry, invented the trusses as a result of long experimentation of gusset plywood and various combination of staple, nails, screws, glue and so on. The trusses was a very important invention and was the beginning of the marketing of trusses and truss in the industries. Now the trusses is implemented in the construction of houses, hospitals and so on. Since then, the trusses industry has gained more and more popularities. Now, the trusses industry is a major part of construction. Now, let us go back to understand. What is meant by trusses. Trusses is nothing but the assembling of two force members, where the two force members are assembled in such a way that it appears or looks as if it is a single unit or a single object. The trusses consist of two or more triangles in a single straight membrane, which is connected, whose ends are connected with the help of nodes. Next will be continued by Sumant.
As my friend Mayur explained about the trusses, let's talk about the truss bridges. Truss bridges are the bridges whose superstructures are made up of trusses. The types of truss bridges are like cantilever truss, outpost truss, king post truss, and T-bridge trusses, and etc.
As my friend previously explained you about what are trusses, I would glad to let you know what are the characteristics of trusses now. The first important characteristics of trusses are the trusses are mainly made up of a straight member where the joint is known as panel joints. The straight member is a successive addition of two adjacent member of a triangle, because there are three equations of equilibrium in a trusses where the two reactions can be found and the two unknowns can be found using three sides of a triangle. The simplest form of a truss is a single triangle because the unknowns are only two and the reactions are also two. Two members in a triangle meet at a joint. The joint is known as the multer joint, and the further information will be shared by my friend Sunil.
Myself, Sunil. I am talking about classification of trusses. There are three types of trusses: perfect trusses, imperfect trusses, indent trusses. Perfect trusses, number of members are sufficient to resist external loads, is called perfect trusses. Imperfect trusses, the number of members less than the required perfect trusses. Redented trusses, the number of members greater than required for perfect trusses. Rest will be continued by Jan.
Now I'll be talking about the types of trusses. They are basically categorized as two. One is the pitched truss and the other one is the flat truss. The pitched truss gets its name due to the triangular structure, and the flat truss gets its name due to the parallel top and the bottom structures. Well, the pitched truss is used in construction of the roofs, and the flat truss is used in the construction of bridges. The next of types of trusses which you see around us are the Warren truss. It is actually made up of a series of isosceles triangles joined together. It is basically used for construction of bridges. The next one we see around us is the octet truss. It basically is made up of equilateral triangles. It consists minimum of two of the tetrahedrons and one octahedron. The next one is the Pratt truss. It is made up of vertical and diagonal columns. The vertical column are responsible for the compression, and the diagonal columns are responsible for the action taken by the tension or action taken against the tension applied on the system of truss. The next one we see around us as the bowstring truss. As the name suggests, it is in the shaped as a bowstring, and it can be found over small rivers or where the distance between two places is very small, and it's also known as the arch bridge. The other one which we look around is the lenticular truss. It is in the shape of a half cut lens, as it gets its name due to the lens structure which it has, and it is also used for smaller distances between two places.
I will be explaining about the application of trusses. You might have seen trusses everywhere, but the first application is in the sports stadium. In the sports stadium, it is used on the top of the roofs for the support of the goods. The second application is used in bike. It is used in bike for the support and rigidity of the bike. Next is the iconic Rameshwaram Bridge, which works on the principle of trusses. The next application is used in railway platform for the connection of the electrical wires. The next application is used in the conventional halls, which is basically known as the Kalyana Mandapa. Further discussion will be continued by Shashank Amravati.
Talk about space frame truss. A space frame truss is a three-dimensional framework of members pinned at their ends. A tetrahedral space is the simple space truss consisting of 6 members that meet at 4 joints. They are employed in base structure of large freestanding 4-line pylon. Practical demonstration is done by our friend.
I'm going to talk about the construction of the member we made. Each member is consist of two different tubes. One tube is bigger than the other one. The bigger diameter tube is split into two pieces, and the end of the tube is flattened. The smaller diameter tube is then placed into the bigger diameter tube along with the spring. The spring is custom made so that it could expand and compress simultaneously. Now I will be explaining about the truss bridge, in which all the members are connected in such a way that it forms an equilateral triangle. The whole bridge is supported on 4 wooden blocks, and 2 support reaction can be seen in there. One is fixed reaction, other one is hinge reaction. Now I'll call my friends Shetty, Ritik and Sumant Ashok to determine the practical and theoretical value. In figure at B and C, we have already calculated the reaction force. Let us assume we are applying a 5 Newton force at point A and 3 Newton force at point D. When we apply to both the forces, we will get the tension and compression in all these members. Now we will practically determine the tension and compression in each member. But before applying the force at the points, we will calculate the length of the string of member AB. 6.5. Length of the string at member BD. 6.5. Length of the string at member DC is 7. Now we will apply force at point A and D. At point A we will add 5 Newton, and at point D we will keep 3 Newton. After applying force, we can clearly see there is some deformation in the structure. Now I will calculate the length of each string in the member and determine which is under stress and which is under tension and compression. AB is 6 cm. BD 7 cm. DC 7 cm. 7 cm. Now we will compare the length of the string with force and without force. Clearly we can see there is a 0.5 decrease in the member AB and 0.5 increase in the member BD and DC. At last we can say that the member AB has undergone the compression
by comparing the value of theoretical and practical. And BD and DC has undergone tension. Similarly, we can determine the tension and compression in other members.